Hello everyone. Today I am going to solve a CSIR NET June 2021 question from real analysis part C. The problem is telling let a function f such that closed interval 0 1 to r be defined by fx equals to x cos pi by 2x if x not equals to 0 and 0 if x equals to 0. Then which of the following options are correct? F is continuous on 0 1, close interval 0 1. F is bounded variation on close interval 0 1. F is differentiable on open interval 0 1, and its derivative f dash is bounded on 0 1, or F is Riemann integrable on 0 1. More than one options can be correct from here because this is a part C questions of CSIR NET. For this problem, we can use a standard result which uh, which is stated that if f is a function from closed interval 0 1 to r be defined by fx equals to x to the power alpha cos a divided by x to the power beta for x not equals to 0 and 0 for x equals to 0, where a is constant, alpha beta belongs to real numbers. Then number one, if alpha greater than 0, this will implies f is continuous function on closed interval 0 1, and this imply f is Riemann integrable. This is a standard result, integrable on closed interval 0. The next result is if alpha greater than 1, this will imply f is differentiable at x equals to 0. And number 3, if alpha greater than beta, here alpha greater than beta, this will imply f is function of bounded variation. Now compare the given problem with the standard function. We can see here x cos pi by 2x. So alpha equals to 1, x to the power alpha. So if I compare these two, then alpha equals to 1, and here pi by 2x. We can write pi by 2 divided by x. So then here, if I compare this with a pi x to the power beta, then a equals to pi by 2 and beta equals to 1. Thus we get alpha equals to 1. These are important. A is a constant term. This is not important. So we get alpha equals to 1 and beta equals to 1. So for this problem, alpha equals to 1, beta equals to 1. Now, since alpha equals to 1, which is greater than 0, this will imply given function f, our given function f is continuous on 0, 1, and thus if I look at the options, f is continuous on 0, and thus option 1 is correct. Option 1 is correct. Hence, option 1 is correct. Next, alpha equals to 1. It is alpha not greater than 1. So this implies if is not differentiable. If is not differentiable at x equals to 0. Therefore, if I look at the options, given options, option 3, f is differentiable on the open interval 0, 1. So this option is wrong. So option 3 is wrong. Option 3 wrong. Now, alpha equals to 1 greater than 0, this implies f is continuous. This also implies f is Riemann integrable. As I discussed before, here the result Riemann integrable if alpha greater than 0. Therefore, continuous on 0, 1 on 0, 1. Therefore, if I look at the options, f is Riemann integrable. So here option 4 is correct. F is Riemann integrable on 0, 1. And option 4 correct. Now, here alpha equals to 1, beta equals to 1. So alpha equals to beta. Alpha not greater than beta. So this implies if is not function of bounded variation on 0, 1. Hence, I think this is the option 2. This is the option 2. Therefore, f is of function of bounded variation. Option 2 is wrong. F is not function of bounded variation because here alpha equals to beta. Alpha doesn't equals greater than beta. This is the condition. I give here this condition not hold. So f is not function of bounded variation on this. This was the problem. Thanks for watching.